What's going on, y'all? It's Mr. Lee. I don't have a video on just cause my camera's not really working well. So we're gonna start with a video for Intro to Quadratics here. This is gonna be for the second day. So I want to do a problem from each type, each form, and that's it. So let's get started. So we're gonna graph and analyze this function. Let's just go ahead and fill all this stuff out. So. All right, the a value is -2. That's the coefficient next to x squared. Since a is negative, it opens down. All right, so the axis of symmetry, remember in this form, is -b over 2a. So -b is -4. 2a is -4, so -2 times 2. That's equal to 1. So this is not your answer, not 1, but x equals 1. So are we going to have a min or a max? Well, we're going to have a max since it opens down. And how do I find this? I'm going to plug in my axis of symmetry into my function. So f of 1 is equal to -2, comma, or parentheses 1 squared plus 4 times 1 minus 9. So this is going to be -2 and then plus 4 minus 9. And that is -11 plus 4. That is -7. So my vertex is going to be 1 because my x value is the axis of symmetry, and the y value is going to be the max, so 1 comma -7. All right, and the y-intercept here, well, the y-intercept is going to be, it's always f of 0. So in this case, it's going to be -9. So it's always going to be this value. So this is the y-intercept for stuff in this form. All right, so now the domain and range, let's do that after we graph. So here's our graph. So what we're going to do is we're going to plot our axis of symmetry first. So here it is at x equals 1. Our vertex is at 1 comma -7, so that's pretty far down. 1, 2, 3, 4, 5, 6, 7. And then our y-intercept's at -9, so 1, 2. So here's -9. And we're going to reflect that across this axis of symmetry to get our third point. And we're going to draw our graph. It's all the way down here. So the domain for this is always all real numbers. So x is an element of the reals. Now the range, since we have a max, it's going to be y is less than or equal to. And what is it less than or equal to? It's less than or equal to our max. So our max is -7. So there it is. Well, it's already in standard form. I don't have no clue why I put this, so don't even write this. All right, let's go to the next example. All right, here's the next example. This is in what we call vertex form. Because it tells us our vertex right here, this is h comma k. So that's the first thing we're going to write down is the vertex. So it's going to be 3 comma 1. All right, and our axis of symmetry is the x coordinate, so it's x equals 3. Our min or max is going to be the y coordinate, so that's going to be, sorry, not y equals 1, just 1. And let's see, we're going to have a minimum because, our a is 2. That means it opens up. So we're going to have a minimum, and it's going to be of 1. So what's our y-intercept? Well, let's figure out f of 0, and that's equal to 2, parentheses 0 minus 3 squared plus 1. So keep going, 2 times 9 plus 1. So this is equal to 19. All right. Yeah, so let's go ahead and graph now. So we're going to plot our axis of symmetry, 2, 3. So there's our axis of symmetry. I know it's pretty bulky, actually. Let's just go ahead and redraw that. And our vertex, so 3 comma 1 here. And our y-intercept's at 19, so I'm gonna redraw this. Sorry, y'all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's gonna be somewhere like up here-ish. Sorry, I'm just guessing. It's way off of my graph. I should have plotted this before. But now we have 3 points. We can go ahead and graph the best that we can. Something like that. So domain, x is an element of the reals, and the range is y is greater than or equal to 1. So we got one more example. So we're going to graph and analyze this last one. So this is in intercept form. The reason why it's called intercept form is because it gives us our x-intercept or zeros right here. They're going to be the opposite of this. So when you factor and you solve for these, well, they're going to be our zeros are going to be -1 and -3. Yo, what's up? I'm sorry about that. Let's continue. All right, so we have our zeros, -1 and -3. What is our axis of symmetry? Well, our axis of symmetry is always going to be the average of our zeros, so right in the middle of our zeros. So it's going to be x is equal to -2. How did I get that? Well, -1 plus -3. That divided by 2 is equal to -2. That's how I got that. So now are we going to have a min or max? Well, our a is equal to 1. So that means it opens up. So we are going to have a minimum. And what's this minimum going to be at? Well, it's going to be at f of our axis of symmetry, so f of -2. So what is that going to be equal to? Let's find out. So -2 plus 1 times -2 plus 3. So this is going to be equal to, so -1 times 1, this is going to be equal to -1. So that's our min. Now our vertex is going to be -2, comma -1. So our axis of symmetry, comma our minimum. And then we're going to do all this stuff after we graph. So let's go ahead and graph. What we're going to do for this is we're going to graph our zeros. So -1 and -3. And we're going to graph our axis of symmetry. And then our vertex, so -2, comma -1. And there's 3 points, so that's enough to graph our parabola. There we go. So now the domain is x is an element of the reals, all real numbers. And the range is y is, so it's going to be greater than or equal to, because we have a minimum. And it's going to be greater than or equal to -1. Now to get this to standard form, all you're going to have to do is basically like distribute out everything, like multiply everything out and then combine like terms. So let's go ahead and do that. So I'm going to rewrite the equation here. So now I'm going to distribute. Also known as foiling. So x squared plus x plus 3x plus 3, and we get x squared plus 4x plus 3, and there's our standard form. Alright, so that's going to be it for this video. Thanks for watching it, and I hope you have a great day.